All right, question number 9. It says we're going to use graphing guidelines to make a complete graph of f. All right, so here we have a parabola. So we don't have to go too deep into anything here. We can use basically some algebraic skills and we can graph this. So we have f of x equals x squared minus 2x. X squared being an even degree, I know it's a parabola. It's positive out front. There's not a negative number or anything. So this graph is opening up. So I know just based on that we have a minimum. We will go ahead and do first derivative. Find that value of the minimum. But again, you can also do that with algebra. Finding the derivative using the power rule, we get 2x minus 2. Set it equal to 0. And we get 2x minus 2 equals 0. Add 2. 2 equals 2x. Divide by 2. X equals 1. So my critical value is x equals 1, or that is the x coordinate of my minimum. That would also be the axis of symmetry if we were doing that part. Now we go back to our original function, plug it in, and find the actual value of that function, of that minimum, that is 1 squared minus 2 times 1. So we get 1 minus 2 gives us a negative 1. So we get an ordered pair of positive 1 for x and negative 1 for the y. I think we can probably graph it based on that. So parabola that is opening up, A is, C and D are opening down, B is also opening up. Let's look at this minimum value. So this is the x or the y axis. So let's see, 1, 2, 3. So each line is counted by 1. So we go right 1 and down 1. That matches. So it looks like A is going to be our answer choice. If we look at D, it looks like it's touching the x-axis, but let's get a better visual. So if these lines are still counting by 1, yeah, that doesn't even go all the way to negative 1. So A is going to be our, sorry, I need to check it. All right, we're good. All right, number 10, we're going to use graphing guidelines to make a complete graph of f. All right, so similar, it's a quadratic. We can probably use some algebra and not have to do all of those steps because it's a lot to go through all of that. Polynomial domain is our real. 576x minus 1120. So yeah, if you were to put this into a graphing calculator, you wouldn't see anything. You would have to change the viewing window, do some other things. I can look at this and say, okay, my degree is odd and my leading coefficient is negative. So we just talked about odd and negative. The left side is going up. So as x going to negative infinity, the y value is going to positive. That's opposite. And when the x value is going to positive on the right side, y value is going to negative. It just flip-flops. So positive goes to negative infinity. These are opposite. So I do know my original graph should be coming down from left to right and then down from left to right on the far ends. What's happening in the middle, can't say for sure yet, but let's see, can we eliminate some options? So this is up on the left, down on the right, matches. B does not, and C does not. Okay, so by process of elimination, we get A. But just in case you go through this, and let's say that 2 of yours are possible, and you got to go through some more steps, let's at least go through the first derivative and find those critical points, and then verify the minimum and maximum, or the local minimum and maximum. So f prime of x, this will give us a negative 3x squared minus 12x plus 576. So here's our derivative. Set it equal to 0. So basically this is a quadratic, and we'll get 2 zeros. Leading coefficient is negative. We don't really want to factor with the negative out front. I'm going to see if we can divide that out. So 0 equals 5 and 7 is 12. Okay, so everything is divisible by 3. Factor out a negative 3. That will leave me with x squared. Factor out a negative 3 plus 4x. Factor out a negative 3. This will be a negative. 3 goes into 5 once. 27 left. 3 goes into 27 9 times. And 6 twice, so 192. All right, so here's our factored form. We're now going to look at factors of 192 to find the factors that when we subtract, we get 14. I'm going to use the calculator to kind of help and speed that out because 192, a little bit big. So what I'm going to do is I'm going to go to y equal. I'm going to type the 192. And we're going to say divided by, I got 193. 192 divided by, and we're going to say divide by x. So the calculator is going to fill in 1, 2, 3, 4 and all the different numbers. And then I'm going to go to second graph to see the table. So I'm looking for whole number combinations, 1 and 192, 2 and 96, 3 and 64. So all of these are the factors. I'm looking for two numbers that have a difference. When I subtract them, I get 4. So these are too big right now. Scroll down this list. Okay, so 12 and 16, they have a difference of 4. So when this factors, 12 times 16 will give us 196. And if I subtract them, I get that middle number, 4. Okay, so I'm going to go back. And then we have negative 3. This will be x, 12, and 16. Since this 4 is positive, and I'm subtracting, I want the bigger number to be positive because I want it to come out positive, and this one's going to be negative. All right, so here we have our factored form. We set this again still equal to 0. We divide by negative 3, that'll go away. But my zeros will be x equals positive 12 and x equals negative 16. So we can verify that 12 and 16. If we look at our graph, x equals negative 16, that matches right there. Positive 12 matches there. And then we could do our sign changes. So I'll just kind of walk you through one of them real quick. Negative infinity, we'll have a negative 16, positive 12, and then infinity. So if we did our number line, I know you can't see that infinity, but it's there. We will pick a number between these that we can work with relatively easily. Let's just say negative 20. Between a negative and a positive, 0 would be easy to work with, and between these two positive, let's just do 20. Multiple of 10 will be nice to work with. We're going to plug these values in to this factored form, and we're looking for positive or negative. I don't care about anything else. So the problem starts out with the negative out front. So I have a negative number out front. If I plug in negative 20, negative minus a negative is going to give me more negative. So I got a negative times a negative here, and then still plugging in that negative 20. Negative 20 plus 16, you'll subtract, and we'll still get another negative. All right, so I got an odd number of negatives. Negative times a negative is a positive. Times a negative again is going to go back negative. So this section is negative, meaning it will be coming down, decreasing slope. Okay, negative slope, which is what we see. Okay, this line is coming down, decreasing from left to right. And then I'm going to do 0, and then we'll stop there. So if I plug in 0 to this function, we have a negative out front, so I got a negative first. Plug in a 0 minus 12, that's still negative. And then plug in 0 here, that's going to be a positive. All right, so negative times a negative is a positive, times another positive stays positive. So this slope is positive. So after 16, it starts going up. So it says we should have a minimum decreasing to increasing, which our function is decreasing to increasing after 16. And so if you kept going, you'll get the rest of it. But that's all we would need to do at this point to get that answer.